Hey guys, good morning. I think it is the day of your big test or the day before, and I'm going to go over very quickly my top 10 list for what you need to know for your district assessment. Number 10, union, intersection, complement, and independent. Remember, union is everything being put together. That's the or. So it's like I get married, all of my stuff, all of my partner stuff together. Union. Intersection is where two things meet. It's like Highway 78, Scenic Highway, that's where they meet. That's the intersection. That's the and, that's the overlap. The complement is what completes the set. So if I have 10 fingers and I have 5 on my right hand and 5 on my left hand, the complement to my right hand would be the left hand. It's all the things that's not in the set that they talk about. So not A. Now, independence, there's a formula for independence. The formula for independence is you multiply the probability of A times the probability of B. If that equals the intersection, then it's independent. But if they give you scenarios, independent scenarios do not relate to each other. I bring my umbrella because it is snowing outside. Don't relate. I bring my umbrella because it's raining outside. Dependent. Independent do not relate. Also independent, rolling a die because one die roll doesn't impact the other. Also independent is replacing. Next, the givens are always in the denominator, and my head's kind of covering that up. The givens are always in the denominator. The givens are always in the denominator. What does that mean? If they say the probability of A given B, B is in the bottom. If they say the probability of B given A is on the bottom. It's like this line stands for the given, bottom. Bottom. It just pushes that letter down. Bottom. Also, if you are given a two-way frequency table, which you should have one question, there may or may not be totals. So you may need to find the totals. If they say the probability of a male, given that he drives an SUV, you're going to have to add up how many people drive the SUV for that number to go in the bottom. Next. The deck of cards. You've been playing a whole lot of peanut butter BS to learn these deck of cards over the past month. What do you need to know? There are 52 cards in a deck, 26 red, 26 black. 52 cards in a deck, 52 weeks in a year, 26 red, 26 black, 26 letters of the alphabet. That's what you're going to need to know. If it says with replacement, you look at the card, you put it back, still 52 cards in a deck. If it says without replacement, you hold the card, and maybe you don't need to count that card anymore. 52 cards in a deck, 26 red, 26 black. The 4 suits are hearts, diamonds, clubs, and spades. Number 8, all circles are similar. I know you said it with me because we say it all the time. All circles are similar. Why are they similar? They're similar because of the ratio to the diameter to the circumference. Remember the formula for circumference is circumference equals pi d. Pi is a number, it's a constant. That's why all circles are similar. How do we prove that they're similar? 2 ways. We have to first do some kind of translation with the centers. Then we do some kind of dilation, gets bigger, smaller. New over old is scale factor. You might have to pull out information. Don't forget to flip the signs. If it's the center, take the square root. If it's the radius, for you to find the scale factor. Special angle properties, I could not even begin to cover all of them, but I'm going to go quick. Inscribed angles have the angle on the circle. If the endpoints are on the diameter, 180 divided by 2 is 90. Opposite angles inside of a quadrilateral equal 180. 2 tangents from the same point are the same. Picture on the bottom. A radius and a tangent form a right angle. If a central angle and an inscribed angle share the same arc, the inscribed angle is half the angle measure of the central angle. P.S. If 2 inscribed angles share the same arc like this, the angles are the same because the arc's the same. You might have one question on in center. In center happens inside of the circle that's inside of a triangle. That's formed by finding the angle bisectors, dropping the perpendicular for the radius and drawing the circle. If you have a circle and you have a triangle, you're trying to get the circle, you got to do the perpendicular bisectors of each of the sides. That gives you the center, and then you can draw your circle from there. Next, arc length. Arc length is the pizza crust. Area of a sector is the pizza pie. If they mention radians, I mentioned in the video today, radians equals degrees. I could do it radians, Degrees times pi over 180. You got to remember the pi over 180, and then you solve with literal equations. You are definitely going to have one question like this. Don't forget, you got to group the x, leave a space, group the y, leave a space, bring that constant to the other side. When you go down, we divide by 2, then we square it. Whatever number we get here, we put on the other side. Divide the y term by 2, square it. Don't forget to bring it to the other side. Once you get your pretty equation, then you flip the signs to get the center and take the square root to get the radius. Parallel cross-section area. There's my head over the circles. I highly doubt they're going to give you the cross-section of a sphere because it's going to be a circle. Nonetheless, if you see the words height, parallel, cross-section, area, you can bet your bottom dollar it's going to be volume. Is the same using Cavalari's principle. So in the problem that we did in the review today, it was the base was the big deal. Don't forget other cross sections. A cylinder can have a circle, oval, or it can have up and down, vertical, rectangle. A cone can have a triangle, vertical, up and down, a circle going across, a pyramid, triangle going down, a square, a rectangle going across, technically a trapezoid going at an angle. A sphere is a circle. The cube is like the specialist shape of all because it has 6 sides, so it's got the most stuff. It can have a rectangle going on the diagonal. It can have a square going across or straight up and down. It can have a triangle by cutting a corner. It can have a trapezoid side to side. It can have a pentagon that's not a regular size pentagon, but it can have a 5-sided shape, or it can have a hexagon. Next, number 3. Slope for parallel and perpendicular. If you have to prove, you'll have one question where you have to prove parallel, rhombus, stuff like that, parallelogram. Opposite sides, you just got to know it. Opposite sides congruent and parallelogram. Opposite sides are the same. Same slope. Diagonals bisect each other. Hint, bisect, midpoint. Add the x, divide by 2. Add the y, divide by 2. Also, you're going to definitely need slope because you're going to have 1 or 2 questions that deal with what's the parallel or perpendicular line. Remember, you get the slope from y equals mx plus b. If it says parallel, the slope is the same. If it says perpendicular, you got to switch the signs and flip it. So that says 3x becomes, instead of it being positive 3, your perpendicular slope would be negative 1/3. After you do that, you plug that into y equals mx plus b with the point. Find your b, plug the new slope and the b into the new equation, and you're done. That problem's going to take you 5 minutes. Just chill, you'll got it. Number 2, density. Density is always the count, the number of items divided by space, volume, area. So how many miles? You can measure how many miles divided by how many hours. How many people live in a square mile? How many balls are in the pit? I don't even have a clue why I wrote liter down. That makes no sense. Also, if you have to switch in the metric system, you are going to most likely always be multiplying or dividing by 1,000. If you have 1 kilometer, we need to multiply it by 1,000 to get to a meter, and then 1,000 again to get to millimeter. Technically, to go to centimeter, you wouldn't multiply by 1,000, you go multiply by 100. If you start at a millimeter, let's say we have 8,000 millimeters and we're going up to meters, we're going to divide by 1,000 because millimeters are so teeny weeny meeny. We want to get to the meters. So we're going to go 8,000 divided by 1,000. It puts us at the meters of 8 meters. Next and finally, the number 1 thing to remember is you worked hard. Take your time. Draw pictures. You got this. And my head is covering up this epic little puppy winking at you because I believe in you and you absolutely got this. See you later. Bye-bye.